Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zulhilmi, ID number TB18124. My partner is Muhammad Ikhwan, ID number TB18037. Now we are going to present about our project for this subject, which entitled Fan Control by Temperature Sensor with Alarm. Without further delay, I will be presenting about introduction, project background, problem statement, objective, project scope, and methodology. Okay, first of all, project background. Arduino has become the most popular microcontroller among electronic users in every less span of time. Therefore, everyone tries to use Arduino to make any project as it is easier to use and easy to get. There are a lot of Arduino projects from basic interfacing project to advanced robotic project with IoT projects in the electronic related website. So basically our project is using Arduino Uno R3, which using three basic components, which are temperature sensor LM35, motor driver L293D, and DC motor. So firstly, the temperature sensor is connected at analog input Arduino pin to control DC motor. Then the temperature sensor will be regulated manually based on the temperature that had been set, and Arduino will read the input signal. Then motor driver that controlled by PWM that connected with DC motor. The motor will be running whenever temperature sensor detect the change of the temperature. So the problem statement is limitation barrier the usage of the fan and produce motor overheat that will cause motor easily broken. So from the problem statement that stated here, we got two objectives, which are first coded by Arduino on monitoring the sequences of the electronic equipment, and second, control motor when temperature sensor detects the temperature of fan motor. For our scope of the project, we are using Arduino as the microcontroller. Second, low cost based project. And lastly, using temperature sensor LM35 to regulate the fan. Okay, for the methodology, first is flowchart. As we can see here, the flow start with the temperature input that had been set by Arduino. And then it go to the temperature scale that had been set, which is increasing by 10 degrees Celsius. And if the temperature more than 40 degree, the fan will rotate, the motor of the fan will rotate forward with 100 duty cycle, and LED red on and buzzer will trigger at the same time. So this is our Gantt chart for 3 weeks period of time. First, project briefing. Second, project discussion. Third, project design. Report draft. Design concept evaluation. Report finalized, and project submission. Next is the list of components that we use in our project. First is fan DC motor. Second is motor driver. Third, temperature sensor. Fourth, LED light. Fifth, Arduino Uno, and sixth, buzzer. Okay, that's all for my part. I will pass our presentation to my partner, Muhammad Ikhwan.
Assalamualaikum. My name is Muhammad Ikhwan, TB18037. I'd like to present about this topic. So, for my part is, so as you can see, this is the overall of our circuit diagram for fan control by temperature sensor with alarm. So below the circuit diagram, you can see the Arduino coding uh, that we use in IDE Arduino software to control the motor, the sensor, and also the LED. So for the result and discussion, uh, the main objective of this mini project is to control the temperature of machine to prevent from overheat. Then the speed of the fan controlled by pulse width modulation (PWM) output regarding to the temperature of the machine, and the LED will show the stage of temperature. Therefore, the LED have three colors, which is green for low temperature, which is yellow for low temperature, green for average temperature, and red for the high temperature. Furthermore, the fan has two stages, which the first fan will active uh, until 20 Celsius, and the second fan will together active when the temperature reach 21. If the temperature over 14 Celsius, the buzzer will be triggered to show the machine overheat. Therefore, when the buzzer trigger, the machine must have defect and need to repair. So for the benefit and advantage to community, the benefit of this project uh, to community is make daily life more efficient when the machine does not need to control the temperature manually by the worker. The benefit of this project to environment is provide a growing social and economic environment in which human can enjoy a higher standard of living and a better way of life. So for the discussion, uh, you can see this is our result for the lowest temperature. So when the yellow LED turn on, the motor one will active when the temperature below 10 Celsius. And for the second picture, the green LED will turn on, and motor one and motor two will active when the temperature above 20 Celsius. And lastly, the temperature above 14 Celsius and the red LED will turn on. The motor 1 and motor 2 will activate and the buzzer will trigger, show that the machine is overheat. So as the conclusion, working of this project is straightforward. To sum up our project, we sure had encountered with a few failures during trying to design and constructing the circuit. But overall, we had gained a lot of knowledge on how to build temperature controller circuit works. We had also learned more on how to use and functions of Arduino Uno motor driver and sensor in the circuits. So based on the experiment conduct, it can conclude that we are now able to understand the motor driver feature, which include L293D and Arduino Uno board as microcontroller. Apart from that, by editing the code in Arduino IDE program and adjusting the motor port connected to the L293D, students are able to monitor the speed of DC motor using microcontroller and motor driver. The L9 the L293D is therefore very good for robotic due to its small size depending on the situation. So finally, we understand the operation of microcontroller Arduino Uno. So make a basic program using C language, draw circuit diagram using Proteus and simulate. So lastly, we know little bit of microcontroller in basic part. So for the last part is summary and recommendation for improvement. For the temperature sensor, we recommend for improve of our project, we can use a better temperature sensor, which is a thermocouple sensor. Thermocouple sensor are the most commonly used type of temperature sensor. So they're used in industrial, automotive, and consumer application. For the motor driver, we also can use L298N motor driver for upgraded because L293D driver operate at 4.5 volt to 36 volt, whereas L298N can be operated at up to 49 volt. So for Arduino, we can use Arduino Mega for upgrade because the Arduino Mega is a great pick for more advanced Arduino intuitions. On board, we find digital and analog pins. The Arduino Mega sport 16 analog pins, essential for outputting analog signal. In addition, Arduino Mega digital input-output pin may be a high as 15 or more. So aside from stellar connectivity, the Arduino Mega features more RAM and ROM than the Arduino Uno and Arduino Nano. So that's all for us. Thank you.